Kevin, welcome back to the show. It's really nice to, I feel like we're really starting to build a community here because we're starting to get more of the listeners just, popping me emails and stuff like that, discussing some of these things on the side. We're having a number of returning speakers now, which is always nice. And it's also really nice for a host because basically when contacting you, it's just like, hey, Kevin, do you want to pop back in and we'll talk about this, like X, Y, Z. And there's no more of that stuff like, okay, is this like a good actor? Does this person like, can we just have a conversation? So yeah, it's really seems like it's shaping up into a number of people who are really interested in just critically thinking on scientific issues and hearing from a variety of people. But I guess great. Today we're going to be talking about more on the demarcation problem between science and pseudoscience and your general willing to change belief on the issue of, whether it's should be focused on individual behaviors versus should be focused more on communal aspects. So how should we kick this off? Here's the thesis. When trying to divide science from pseudoscience, we shouldn't be worried too much about individual behavior. It's more about the community.
Yeah, and that's broadly how I think about it, because I think one of the problems that the demarcation problem faced, and the reason that philosophers have largely, I think, moved away from especially the very traditional ways of looking at it is, traditional ways of looking at it focused on features of either the theory itself or features of an individual scientist. So the idea was either the theory was falsifiable or not. That was sort of Karl Popper's idea, or an individual scientist responds to evidence. But one of the things that some philosophers of science and historians of science have started to point out is that actually when you focus on the individual scientist level, it's very hard to say whether bad behavior is sort of good or bad for science. That there are actually cases of things where you look at them and you say, oh, that looks like bad behavior, but it was actually productive for the scientific enterprise. So one of my favorite examples is one that philosopher Miriam Zollman has a couple of papers really articulating, which was the theory of continental drift. So early on, they recognized this idea that, hey, look, it looks like South America sort of fits into Africa. And if you look at the distribution of plants and wildlife, there's actually some similarities. And so that might lead you to think that maybe they were connected to one another. But when the hypothesis was first proposed, it was roundly rejected because the geology of the time said this is impossible, right? There's just no mechanism. They thought the Earth was solid, so that the forces that would have been required to wrest apart Africa and South America were just impossible. And so the physicists and geologists were just like, nope, this, we see it looks like it, but it must be an interesting coincidence because all of our science says not. And then there was one scientist who just ignored the data. He just said, nope, I'm ignoring that. I believe this so fully that I'm just going to pursue it and pursue it and pursue it and pursue it. And boy, that looks bad, right? That looks like classic pseudoscientific behavior. Like, I have a theory. The theory is roundly falsified by other scientific theories that we have now and by the data, but I'm going to refuse to believe it and just continue to push forward. And it turns out he was right. And so, there are this isn't the only case, but there are lots of cases like this. And so it makes you think well, was he engaging in pseudoscience? Should we have condemned him? Should he have been cast out? And he was was cast out. But, it turns out that he was right. And it turns out that his commitment actually, it's not just even an accident, but his commitment actually led to just new discoveries because he just sort of refused to give up on this idea and kept pursuing it. And just to interject on this idea real quickly. So I just, because previously we've talked about issues with like induction, deduction, and this is an interesting aspect because basically deductively, essentially they said, we have the physics here. We know about the forces that would be required to literally pull these continents apart. And given that we know that there aren't like Greek titans shaping these things and stuff like that, this isn't like, we know deductively from what we know about physics that this can't be the case given what we say, basically, we know the Earth is solid. So obviously we can see right there where some of these assumptions can go awry. But we know that the Earth is solid. We know that the forces to essentially move these solid things, it would be immense.
Because it wouldn't be as easy as, I don't know, just sliding it more over a molten layer or something.
Yeah, exactly,
and so we have that. Deductively, it was not reasonable. Evidentially, it was not reasonable. I guess, well, they had some evidence. Like if you want to say, well, these two little cookie cutters fit together. But, again, both deductively and a lot of inductive, there's an inductive basis to this as well. And still, it's basically soldiering on. It's like, well, is this person being super squirrely? Or is there some intuitive element to this that they are actually going to get right? And, obviously, if he didn't even get, he couldn't even gone his entire lifetime without getting that, getting verified on that. So anyway, I just think that's an interesting. But yeah, let's soldier on, just like he did.
Yeah, and no, I think that's a really good point, which is that it's there are both inductive and deductive arguments at place, which is one of the things that I think is really important about thinking about scientific practice in general, which is this idea that it's not wholly inductive and it's not wholly deductive, because why did they think that the Earth was solid? Well, that was kind of an inductive argument. But then once you have that, then you can use deduction to do mathematical proofs that say these forces are just impossible. But anyway, just this example is an interesting one, because I think that any kind of demarcation criteria that you would come up where you would say, is this an example of good scientific practice by the individual? It's probably going to turn out that you say that this guy is just doing the wrong thing. He's ignoring the evidence. There's very good evidence against his hypothesis, but he's doing it anyway. But it ends up being good for science as a whole. And so as a result, some folks, Miriam Zollman is one of them, I'm one of them as well, tend to think that when we think about like what counts as good scientific practice, or if we wanted to, extend it to questions about like demarcating pseudoscience from regular science, we shouldn't actually so much think about the individual person and whether that person is sort of behaving good or bad, but rather the social structure that they're in. So that is, you've got this person who maybe from an individual perspective is behaving badly, but the question is, what is the group going to do with it? So in bad cases, in what you might think of as pseudoscience cases, that person can, even though they don't have evidence for their hypothesis, sort of gain a large following. And people tend to believe them not in virtue of the evidence, but just in virtue of their personality or something like that. Whereas the scientific community was actually behaving well in this setting, they didn't believe him because the evidence was against him. And so they said, look, you can do whatever you want. Like, you're a person, go ahead. But we're going to not believe you until you bring us sufficient evidence.
You can do whatever you want. You're just going to do it without tenure.
Yeah, exactly. You're going to do it without tenure. We're not going to give you grants. And this is actually one of the things that people sometimes worry about with the current structure, is that the current structure, that really depends on tenure and grants and outside funding and all of this, actually makes it harder for people to go out and be crazy in a certain sense, because sometimes the craziness is right. But this is the problem, right? You don't want to just reward craziness for craziness' sake either. There are plenty of, we don't need the European Research Council or the National Science Foundation giving money to flat earthers or something like that. We got to figure out where the boundary is. But the broad sort of point here is just to say, like, when you look at good science versus bad science, or science versus pseudoscience, or any of these kinds of trying to demarcate, the good method from bad method, if you focus just on the individual, you may end up throwing out behavior that ended up being productive, as well as behavior that's bad. I mean, there's plenty of people that pursued larks that were totally wrong. And there are famous cases of people who refuse to believe the evidence and things like that. Ernst Mach is this famous example of somebody who his entire life refused to believe in the existence of atoms, even long after sort of everyone had said, even the physicists were actually slow to believe it relative to the chemists. It's sort of an interesting case. But he was recalcitrant for long after even all the physicists had believed it. And that's a case where you sort of say, look, this guy just wasn't responding to evidence, and it wasn't productive. He was wrong. Atoms exist. But it's sort of interesting to sort of say that, like, when you think about what's good and bad science, maybe focusing on the individual actor is the wrong thing. And that's the sort of line that I'm trying to push, is that think about the community, which will contain bad actors as part of it, or what you might think of as bad actors, but that the community as a whole might actually be made better by the presence of some bad actors in a sense.
And is one of the things is you might have heard about that sort of famous case in the last decade where essentially basically mathematicians were coming forward and they essentially had proofs that the rest of their community couldn't follow. And so the question is like, does this constitute a proof if no one else gets it? And so I guess as part of the intuition behind this sort of communal aspect of science, also recognizing that a certain number of people have to be on board with a theory in order for it to say like, this is a learned aspect, like our civilization has acquired this.
For sure. And that's an important part of science. And this is actually, I think, one of the things which is really important is that, what makes a good community is that the community is not necessarily immediately responsive to evidence, but in the long term is responsive to evidence. And I think that that's an important distinction. So that sometimes in the short term, it's good for some people to be holdouts, and it may be good for people to believe a theory, even though the evidence is against it, or to refuse to believe a theory, even though the evidence is for it. And that's good in a sort of temporary or short-term period. But eventually you need it to be the case that everybody either gets on board or doesn't. Because if it's just the case that you're going to disagree, for forever in perpetuity, then that's not a good idea. And this actually connects to the statistical idea, this learning in the limit idea, which you see in statistics, in Bayesian statistics, but also statistical consistency in terms of estimators, this idea of like, well, it can be wrong for a little while, but in the limit, it's eventually going to be right. And I think you can think of the same thing from a community standpoint. The community can be fractured, can disagree, it can have members that are being recalcitrant, but in the long run, you need it to be the case that eventually they all come to agreement.
Yeah, when I think about basically the idea of like recalcitrance in scientific communities, the one that I actually think of is more of the idea that everyone deserves a defense attorney. So, and that it's not just enough to have a public defender. It's like you kind of want the best one that you can have. And so the idea is that there is value in essentially multiple theories having vigorous defense in their favor. And that is what is going to really met these things out. And so you wouldn't want everyone to be like, oh, I immediately need to jump to, for example, like a data-driven approach to science, where the moment a new piece of data comes in, everyone piles onto that. That doesn't seem helpful.
No, that's exactly right. And there have been a couple of different philosophers, Miriam Zollman, who I already mentioned, is one of them, Philip Kitcher, myself. Bunch of folks have started to focus on what Philip Kitcher called cognitive diversity, or the division of cognitive labor in science, which is that you really want it to be the case that you have difference of opinion, and I sort of articulated this as the value of what I call transient cognitive diversity. That is, you don't want people to disagree forever, but you also don't want them to agree too fast, because if they agree too fast, they're going to abandon potential avenues. And the example I give is the history of peptic ulcer disease. And that's a case where one study came out that convinced everyone that bacteria can't live in the human stomach. And so everyone said, oh, that must mean that ulcers are caused by stress or excess acid. And it was almost 50 years until that study was eventually proven to be wrong, and that ulcers were actually caused by bacteria. And so that's a case where, everybody jumped ship too fast. And there were, a few little recalcitrant actors here and there, but everyone kind of ignored them because they said, no, we know this can't be possible. And it wasn't until some kind of bizarre outsiders, came along and said, no, we think a different theory, and we're eventually able to prove it. But, it's there are cases where it's like scientists jump ship too fast. They all get on board with the theory, and it turns out that theory is wrong. And we would have been better if we had sort of said, well, it looks likely that theory is wrong, but let's assign it a defense attorney, or let's admit somebody who's a defense attorney for it, just to give it its fair hearing.
Yeah, actually, that reminds me of when I was doing some of the reading on this. One of the distinctions that I saw was that the idea that pseudoscience tends not to progress from the basis of other scientific disciplines, which is interesting because you can take that both ways. Like, yes, it makes sense that it would be a bad piece of science, for example, in the life sciences, when you see a publication where there are deductive mechanisms known to the extent that we know that we've collected evidence that these mechanisms exist and they behave in a certain way. And so we have a pretty strong feeling about those mechanisms. And then you have another paper out here, which effectively explains another causal relationship that is completely against or completely ignores those mechanisms. And I'd say by and large, my intuition would be to say that this new paper is probably the one that has, jumped the shark or something like that, where it's just this one that they don't know enough about the mechanistic elements to actually come to a correct conclusion. However, the peptic ulcer one that you're talking about is essentially, it's a counterexample to that, but I would say that's a counterexample that was preceded by someone directly attacking the assumption. So I think that there's one thing, and maybe that's useful thing, is I just sort of free think here that if you're explicitly attacking the assumption based on another mechanism, that seems more plausible than if someone's literally just wandering off and publishing and you just haven't done your lit research yet or connected the dots.
Yeah, and this is, in the peptic ulcer disease case, that's an interesting one, because there were a couple of cases in the interim, between this paper that said that bacteria can't survive and later the discovery of that they can, where doctors were reporting, I've successfully treated my patients' peptic ulcers with antibiotics. And of course, people would say, how could that possibly be? We know that bacteria can't survive in the stomach. So that's, like you said, there's like this underlying mechanism where people are rejecting it. And the doctors, of course, are like, look, I don't know. I just gave them antibiotics and it worked, And so
I give for peptic ulcers. I give them for a cold. I like antibiotics.
Well, and this is, one of the cases that I read this interesting sort of collection of people that were like, let's look at all of the intervening stories of people. And, there was this Greek doctor who treated all of his peptic ulcer patients with antibiotics and apparently wrote an article that he sent to the American Medical Journal of the American Medical Association, that detailing that he had been doing this, and the paper was rejected. But we don't have a copy of the paper, so we don't know. Like, was it a well-written paper, or did it? It could. Nobody knows this guy, so maybe he looked like a crackpot.
Yeah, I mean, the control group might have been hamburgers or something like that. So,
exactly. You have no idea. But that's exactly the problem, is that there are these things where it's like there was little scattering bits of evidence that people rejected because they said, well, there's this underlying mechanism that we think we've proven. And it turns out, that's an interesting case too, where it's like they were wrong, but not radically so. So the theory, the kind of going theory, at least so I'm told, the going theory at the time was there either will be lots of bacteria or none. And so they did biopsies and didn't find any bacteria. And so they said, okay, it must be none. But it turns out there's one, the one that causes peptic ulcers. And so they missed that one. But they missed it because they themselves were relying on a further assumption that turned out to be false. And so it's like, there's this sort of complex relationships between the assumptions that you're relying on and diversity about those assumptions. If somebody had come along and said, this is a great study, except, what if there's only one? Then maybe somebody could have noticed it. But that, it wasn't actually until much longer that people sort of went back and said, what was wrong with the study? And they figured it out.
Yeah, this reminds me actually a bit of, the benefits of a liberal arts education, where I had to take my one philosophy class. And first his name, I think, was Noah Lamos. And he was, he's basically saying, give us like a few instructions. Like, one, don't try to be smart. Just bullet point your argument. Like, make sure it flows, and just write it in good short words. And just, and to some extent, I wonder if our scientific community would benefit from that directive in a way. And the idea that, instead of basically saying we do all this, we do this study, we collect this data, if people actually said explicitly, here are my set of assumptions. And the idea was that instead of maybe, that background thing, the lit review of a publication, you just say, here are my strongly stated assumptions. I proceed from those assumptions and collect this data. And that if I know that if the data says this, I will then reject my hypothesis. If it says this, I will either be ambiguous towards it or whatever. But the idea is, too many times our assumptions actually sort of get brushed over with all the other trappings of scientific writing. And so I wonder if maybe if you just pull those trappings away, say, here are my assumptions, let's rock and roll.
I think that's really right. And I think one of the things that a lot of both psychology and sociology research has started to show, which I think is valuable for us to think about with science as well, is that it is very easy, even philosophers who are carefully trained to articulate every step of the arguments, it's very easy for us to sneak in an assumption that we don't realize that we're sneaking in, just because it's our background assumption. And so that's part of the reason why having a community of scientists that have different background assumptions can be really, really valuable. There's a really interesting case. I'm going to forget the name of the scholar who wrote a book about it, but it's an interesting case in animal study of animal behavior, where just like all scientists, all the early studies were done by men in the 1940s and 50s. And when they studied this animal community, it was a primate community, they just assumed that sort of the male primates were in charge, and they described the community structure all in terms of there being an alpha male and da. And then a woman primatologist comes along and says, "You've completely misunderstood this society. It's actually the female primates are in charge. It's actually the males have a subservient role," and re-described it. And in fact, that's now the view of this particular primate community. But it was because the men were going in with this sort of view of like, oh, the primates must just be like us. And especially in the 40s and 50s, Western cultures were very male dominated. And so as a result, they're just like, oh, okay, we're just going to operate under this assumption. And then they tried to describe everything that was going on in those terms. And so, it's a great historical example where having people who have different backgrounds or who view the world in a different way can help to point out the hidden assumptions that others are working with that they don't necessarily realize that they're working with. And so, I agree with you. Like you said, it's very important to, be careful to write down all of your assumptions, but also it's good to have, I really like your analogy of the defense attorney, have somebody who's on that other side, whose job it is to say, you think you wrote down all of your assumptions, but here's one that you missed. Precisely because in cases like peptic ulcer disease or cases like this primate study, there's an assumption that's sort of hidden away in there that turns out to be wrong. And we got to have somebody to point it out and say, look, it's not necessarily that it has to be wrong, but it needs evidence itself. You need to look for evidence for it. Or if you don't have evidence for it, you need to consider what would happen if it was false.
Yeah. Actually, from the moment you gave the primate example, I could not get out of my head the idea of those guys with the explorer hats, putting these monkeys in little tweed suits and saying, "Look, they're exactly like us." But yeah,
no, and it's really true that there are lots and lots of examples in the study of animal behavior where people just, especially with primates, project onto them the assumption that their sexual behavior or their social structure or their individual behavior must be a lot like us because primates are closely related to us and they kind of look like us. And there is some behavior that is quite a bit like us, but we always need to entertain the possibility that they might have radically different social structures. They might not be monogamous, so they might not be male dominated, or they might not have, atomic families in the way that, 1940s and 50s America imagined that it should be. And so, those sorts of things are important because by having people that come at it from very different perspectives or that entertain basic, very different structures. I mean, look, there are some primates that do look a lot like us, but there are some that don't in terms of their social structure.
Yeah, actually, just because we might as well just sort of dig down on this one a little bit. I think there's a term for it. It's anthropocentrism. I know, anthropocentrism, the idea that when we're studying animals, we tend to impute our own characteristics on them. And the idea is there's two ways to look at this. One, that it's a silly idea because they are birds and we are humans, or they are monkeys and we're great apes, things like that. Yeah. I don't know. I don't even know if humans actually get to be counted as great apes or not.
I don't remember all these classifications either.
It might just be the lucky four then who get to be great apes. But again, the idea is you might say those are absurd because they are definitionally different. At the same time, you might say, well, many of the same Darwinian processes that have allowed one species to persist over time would allow another one to, and while making accommodation for some small deviations, there's no reason to believe two species can converge on similar behavior, similar to how species will converge on behaviors like hunting and things like that. Like they just eat other critters or they dodge other critters. And so you could go both ways with this. And there's a good foundation for both. And I guess the question then is, do you have one person who puts on the feathered humans hat and one who puts on the completely distinct hat, and then they have a moderator? How do you sort through that?
Yeah, that's an interesting question. I don't know this field super, super well, so I may be sort of just talking out of school here. But my sense is that actually that is kind of what happens in a lot of this literature. That you really do have a lot of people who are very much sort of like, I'm going to say that these animals are completely different than us, especially in animal cognition literature. So that's people that are like, how do primates learn? How do other animals learn? You have a lot of people that are like, no, their cognitive mechanisms are very different. They learn in a very different way than humans. And others that are like, no, they're just like humans, except they're missing like one little thing. And, I've read a little bit of the literature about like animal languages is a big area where this gets debated. Like humans have in a certain sense, a very different languages than animals do. If you want to even call it animal communication language. But there's this question of like, is it fundamentally different kind, or is it just sort of like where you turn the volume up on a couple of things, and it turns out that gives you a lot of power. And there does seem to be sort of two camps. There are ones that are like, it's fundamentally different. I don't know if he still thinks this, but Noam Chomsky was one of these people who was like, no, really, human language is different because it has some kind of grammatical structure. But then there are other people that are much more like, no, the animals have grammars and things like that too. It's really just that humans sort of seem to have crossed some kind of threshold that gives us this really rich expressive power, but it's not like a fundamentally different kind. And I think that those debates are really helpful precisely in this analogy of like, if everyone just assumes they're just like us, then we're going to find a bunch of examples of how they're just like us, but we're going to miss all the cases where they're very different. On the other hand, if everybody were like, oh, they're totally different, and that's what you get in 19th century and before, the early theories of animals were the difference between animals and humans, because humans have a soul and animals are just like robots. And so they're going to be mechanical and in ways that humans are not. And this was a popular view in at least Europe and the United States well into the 19th century, I think. And, that's wrong too, of course. And so, this having a balance in the community, I think is good because it sometimes forces people to debate. There's this new idea, which I haven't seen it done a ton, but people are starting to think about it. They call it adversarial co-authorship. So the idea is that you take two people who have really different views. One accepts a theory and one rejects it, or they have competing theories about something. And then they agree, we are going to co-author a paper together, which is going to design an experiment to resolve this dispute. And the whole point is, it's like ahead of time, they agree, like we both agree that this experiment will resolve the dispute. And then they conduct the experiment and then they write up the paper. And the idea is supposed to be that by putting two opposing authors in dialogue in that way, you can help them to design really useful experiments that maybe neither of them would have designed on their own, because they're operating under this, with assumptions that maybe they don't even articulate until they're put in dialogue with somebody who disagrees.
Yeah, that is a really interesting idea. I've not heard very much of that, but those are the types of solutions where it seems like we do need to be revamping how we do conduct scientific research, and that seems like a way forward. And obviously it doesn't, the main problem is that it doesn't fit into our sort of very rigid form of scientific publication, where at the same time that's scientific publication's fault, not the actual dialogue's fault. Like that issue's on them. Because you could imagine that, like, for example, say someone who, just to use our running example, say that there's someone who very much wants to use the idea that these animals are so cognitively different that we shouldn't be imputing our own sort of assumptions on them. But at the same time, by not using human beings as some type of reference, human beings as a reference have one particular value. We have a lot of transparency into human beings. I mean, like, we're all a bunch of crazy critters anyway, but the fact is, we can at least conduct a wider range of experiments. We aren't such a closed box as the mind of, a chickadee or something like that. And so the idea is there might be useful inferential methods that at the very least can say, okay, well, this sort of works for humans. We can now test these piecemeal on your favorite golden finch and see which of them sort of pan out, which of them don't, and so on. Maybe just to sort of jump tracks a little bit on this topic of communal elements. One thing that I really wanted to talk about more is sort of the institutionalization of science. So scientific institutions and essentially how they influence the trajectory of science, because it seems to me, I come from an economic background, and in economics, the purpose of institutions are to provide stability so that people can basically do things, regularize societal activities. And that's for the value of institutions. They always say, what determines a successful society? Well, one is strong institutions. At the same time, and this seems very pertinent to what we're talking about right now, the institutions provide stability, but excessive stability is the antithesis of scientific progress. And so essentially there's a balancing act here. I didn't even ask you a question. I just made some statements and I'll let you respond.
Yeah, no, I agree entirely. And I think that this is the real paradox of scientific institutions like National Science Foundation or the European Research Council or any of these kinds of big, oftentimes governmental, although they don't have to be, organizations which fund science, is that they bring both a virtue and a vice. So the virtue is that they provide the financial stability and incentives for people to conduct the kind of research that isn't going to pay off in the short term. So look, industry is good at producing certain types of scientific. They will produce scientific results that are going to pay off in the short term financially. And so, computers got better despite the fact that, and are getting better every day, despite the fact that there's not a ton of governmental funding to make computers better. Why? Because if you can make a faster or a fancier computer or whatever, you're going to make $1 gazillion in the next couple of years. But of course, there are scientific advances that even if they do have financial gain, that financial gain is sometimes centuries away. I mean, I've forgotten exactly what the time frame was, but from like Einstein's conception of general relativity to the first industrial, use of general relativity was almost a century, I think. GPS satellites had to use them. So maybe it's 80 years or something like that, right? And so that's not the kind of thing where you expect capitalism or industry or anything like that to produce those kinds of scientific results. So you want things like National Science Foundation or European Research Council to fund things so that we can have a longer time horizon. And also there's important scientific advances that just aren't going to ever be profitable, but where we still want to know them. And so we want to have science for that purpose too. But exactly like you said, the other side of the coin is that those institutions can sometimes be very conservative because they face their own weird systems of incentives. The people who are making the decisions about what to fund they're not going to get pat on the back if they spent a bunch of money on a crazy idea that was wrong. And so, they want to be conservative too. And there's been a lot of debate, I know, here in the US, especially about the National Institute of Health that funds medical research, about its conservatism, in that it tends to focus on, like in cancer treatment, it tends to really focus on chemotherapy and radiation therapy and not on these sort of more radical ideas that may turn out to be bad ideas, but may turn out to be right. And I mean, I don't know enough to know whether these complaints are legitimate or illegitimate, but it's an example of things where people are really concerned that these things, that our dependence on them also creates a real type of conservatism, because you have to, they look in some ways like industry. You have to, you get a grant, you have to submit yearly reports, you have to say what progress you've made, you have to, and so if you say, I'd like a grant for this crazy idea, and then the crazy idea fails, and your yearly report is, yeah, I guess it didn't work, it's not good for your scientific career, and it's not good for getting funding in the future. So I think it's a really difficult balance. And I think it's a really tricky thing, because I wouldn't want us to abandon, the federal funding or national funding or for science. I think it's very important that we do that. But also, I think we have to conceive of it as a little bit more risk-taking. We want to fund the things that wouldn't get funded otherwise. So they have to be long shots. They have to be long-term. And so, people have talked about different ways of thinking about it. Like, do we maybe give up on the grant system and switch to what some people call a prize-based system, which is if you make a scientific advance, we give you money and tell you do whatever you like with it. I mean, you got to do science, of course. Don't buy a yacht, but you can sort of, this is just your money to pursue your crazy idea. And, that's got its virtues and its vices too. But this is part of that conversation of trying to figure out how do we balance the desire for this kind of diversity, but also, making sure that we're not just funding crackpots.
Yeah. Sorry. Again, when you talk about it, so you can't buy yachts, it's like, well, what about the research if yachts make scientists happy? Is that something important? But I guess here, like, just because we're just having a straight up conversation, one of the things that I think sort of clouds this issue is, and like, I don't like talking about politics. I like talking about science, but there is an issue where there's a second order consideration here, where when people are talking about the efficacy of, for example, the National Science Foundation or any of these governmental bodies, that there's one issue, which is basically, are they making scientific progress in some way, shape, or form? And to me, that seems like the answer is a pretty straightforward yes. Are they progressing towards the things that are correct? Like, where should they be heading? That's a separate issue. But like, is knowledge being generated in some way, regardless of the cost? The answer that to me seems to be yes. I can't tell you about the cost-benefit ratio, but I can tell you that at least like there is a benefit to it. But I think that one of the things that sort of clouds this issue is the fact that there's a second order consideration here, which is effectively subsumed by subjective beliefs of the holder, which is essentially there's a faction of people who are extremely skeptical of government-based science and whether or not sort of essentially a federal body should be determining the direction of science. And there's a second body who are extremely skeptical of the value of private enterprise in pursuing science. And essentially the idea is like, well, if industry has a monetary reward aspect to it, that surely this must corrupt it in some way, or at least misdirect it in some way. And I think both of those are actually fairly laden with subjective valuations. Like, I don't think either of those views are particularly rigorously vetted, where they say, someone could have a monetary incentive, and that's maybe the best incentive you would want if you're trying to get good bang for your buck. And there's also plenty of evidence that people do make long-term investments. Warren Buffett's not a day trader. So the idea is like there are, when we make assumptions about these underlying issues, we are imputing a lot of beliefs, and many of them are in fact as false as anything that we can have out there. So, and I think that part of the issue is when people are trying to discuss like how effective is the National Science Foundation or this, that, or the other foundation, part of it is that there is a secondary battle that they're fighting, and they don't want to compromise this other goal that they have.
Yeah, no, I agree. And my own personal view is sort of somewhere in the middle. I think that, that industry in the history has done good science. There are great examples of industry science. Bell Labs invented the transistor. I mean, our whole modern world, is as a result of that. And so, like these, industry has done good things. Now, industry has done terrible things, right? The history of industry-funded science about the safety of cigarettes, for instance, is just laden with disaster. And
sorry,
so
I'm in North Carolina. Your audio just cut out.
Yeah, right. yeah, they've got a finger on the button.
Yeah,
but that's it's exactly these kinds of things but also government-funded science. There's lots of examples where that's really gone awry. And so I think that the political discussion oftentimes is like exactly like you said. It's an oversimplification of both sides. That is, industry is good at funding certain types of science. It needs to have checks and balances because we got to worry about how industry's short-term profits may conflict with goals of truth and things like that, as in the case of the cigarette industry. But also, to sort of say that no science should be done by industry or no science should be funded by industry seems to me a mistake. It's leaving out opportunities to do good science. But also, on the other hand, there's lots of science that's been done by the National Science Foundation that would never no industry is going to pay for us to find the Higgs boson. Like, no one has any idea what we could do with it. Maybe nothing, but maybe in 50 or 100 years, knowing that the Higgs boson is going to be there is going to make somebody $1 gazillion. I don't know, but that's kind of the point. Nobody knows. And so we want to do that basic science so that we can, eventually, hopefully, make use of it in one way or another, whether that's financially or non-financially. So I think that, a recognition that no matter how you fund science, whether it's, and there are other models too. I mean, there's the 18th century British model, which was just let people do this as a hobby and pay for it themselves, right? And
those really were the people who were dressing monkeys up in their little tweed suits and saying and stuffing them and things like that. Yeah.
And some good science got done in the 18th century in England too. And so, it's not.
But those same people got up to a lot of mischief as well, to put it extremely lightly.
Oh,
yeah. But yeah, sorry, go on.
For sure. And that's the thing. It's like every way of funding science has its virtues and its vices. And probably the best way to fund science is a mixture of them, where we recognize each virtue and its vice, and we try and design the system to try and maximize its virtues and minimize its vices. And so I think that, this is one of those things where, and also for the same reason that I say that I want, individual scientists to exhibit diversity, cognitive diversity relative to one another. I also think that funding bodies might want to exhibit cognitive diversity. So, Bill and Melinda Gates Foundation is funding very different things than National Institutes of Health. And I think that's a good thing because, the fact that they're taking different approaches to problems and different approaches to the way they fund science is good because it means that we've got different approaches at the scientific level. And so having multiple different institutions that fund science is itself something that might help to generate that same kind of cognitive diversity that we want at the scientific level, because now we have different people that are pursuing very different tactics in terms of funding.
Yeah, I guess just to summarize my main thought on this, I very much liked having the conversation, but just like when I said before, a paper where they actually outline what your assumptions are. I just wish that there'd be more of that in the conversation where someone would just say, like, look, I'm a professor. I get this type of federal grant. Well, everyone knows that. Like, if you're a tenured professor at some point, like, you found your way to that train. But and just say, like, look, I'm generally in the belief that government-funded research, it explores certain parts of certain phenomena that industry will never touch, and I don't want to compromise that. And just say, like, and I don't want the conversation or any of my research to compromise that second order issue. At the same time, allow me to discuss this issue, for example, like whether or not project A versus project B was an efficient thing to fund. And so the idea is, like, you can take a crack at whether or not a specific instance was well or ill conceived without essentially compromising these further issues. And so I wish there was a little bit more of that conversation. And then we could just have stick the topic at hand and just everyone realizes we're in a safe room. It doesn't leave this. It's like Vegas.
Yeah. And I think it is important because I think that it's this is something which I do worry about a little bit, especially the way that some people pejoratively call it science by press release, and I don't love that term, so I'm sort of cautious about using it. But science. One of the things we've seen recently, and especially with the pandemic, but also it was happening long before that too, is that there's a lot of incentive for the universities, especially, to be like, we have discovered this amazing new thing, and so put it out in a press release. And the thing I sometimes worry about is that especially as we shift more towards that and wanting to get public excitement for my research, which of course I want to, is that it disincentivizes scientists from that honesty that you're describing, saying like, look, I think I've proved something important. I really do believe that, but I also admit that I'm relying on this assumption, which maybe needs more investigation, or there are these limitations to my study that, I haven't eliminated every confounding variable or something like that. So finding a way to incentivize that balance between like, you can honestly say, I think I've done something important, but also it's good to be careful and it's good to be forthright about your assumptions, precisely because we all know that sometimes your assumptions are wrong, and sometimes and science is not benefited as a community if we're incentivized to hide our assumptions. So I think it's really important for science to try and, incentivize scientists to be a little bit more honest. They can say, of course, that they thought they made this really important discovery, but also to be honest in articulating, these are the assumptions that I'm making, and these are the places where my argument might be wrong or might be, subject to critique or something like that. And finding that balance is really tricky because, of course, we do think that we made new advances, and we should be allowed to say that we think we did. But also we want to encourage that, digging into our assumptions to see if maybe an assumption that we're making is wrong, and be honest about the limitations of our studies in terms of, we didn't test for every potential confounder, or we relied on assumption about the structure of our data or something along those lines. Because, that's how science progresses when we dig into those things. And so figuring out a way to balance that, to allow scientists to both articulate that they really do think that they succeeded, but also to encouraging them maybe to be more honest than we do now in terms of the assumptions or the underlying ways that they could be wrong. And I feel like that's one place where I'd like to maybe see us sort of shift back or shift a little bit towards more honest assessments of, here's my argument, I think it's right, but here's where it could be going wrong.
Yeah, I think that is that is helpful. Now we just need, obviously, to start creating the structures that will actually incentivize that. Unfortunately, I think that we'll probably have to forego some of the discussion about incentives. I think we could delve into that a lot more. For example,
sure.
One of the things, just to pop it off the top of my head, was the idea that different scientific institutions, and now I'm just talking broadly, institution, organization, a group, random person doing their own hobby science. There are different incentive structures to growth in those. And not all those incentive structures, just as like we're well aware that the financial incentive of corporations might compromise the integrity of their science. But similarly, there are other incentives, for example, like the incentive to grow within an organization. And while there's one route by which you grow as a scientist by becoming more scientifically rigorous and being profound in your area, you could also grow in your career by essentially becoming an administrator of some sort. And essentially, there's administrative tracks. And so effectively, if your comparative advantage is not as a profound scientist, but in fact, you might have a better comparative advantage simply pursuing an administrative task, or basically creating these bifurcated roles by which administrative leaders are effectively actively selected out as not being the best scientists that we have available. And obviously, I think that would have to be done on a case-by-case basis and rigorously. But from a sort of an economic perspective where people pursue their comparative advantage, it's hard not to acknowledge that that might be a plausible mechanism that anyone can reject with evidence. But yeah, actually, maybe just for our little, because I know we only have a little bit of time left. But one final aspect of the demarcation and sort of the community problem is the fact that our society has a number of communities, and not only do we have a number of communities, but we have a number of communities who have essentially been on the vicious end of scientific endeavors. And effectively, where by virtue of us dehumanizing certain populations, we've been able to pursue scientific endeavors at the expense of other people. And so I guess, and I'll bring up one thing, and this is a bit convoluted, but quick example in pseudoscience where the idea of like a flat Earth, where now anyone with our access to satellites can see the Earth is not flat. However, there's also plenty of evidential reason prior to these things to believe that the Earth is flat. For example, like you can just march off in one direction, and if you're going by foot, you're not going to find yourself back on the other side, unless you get lost. But the idea is that there are, just as a toy example, there are societies for whom this evidence, actually sort of the cutting edge of science, does suggest this other thing. And so effectively that the demarcation cannot be so solid as to basically say one community is scientific, that our ancestors were pseudoscientific simply because they haven't discovered what we have anyway. But there's an element here where there's a societal comparison here where basically one society believing A is not pseudoscientific, one society believing A is scientific. And so I guess, again, it's an open question, but how do we sort of start parsing through these things? I gave a toy example, but obviously in reality, it's much more complex.
Yeah, but it is, I think, this is one of those things which is really, really tricky, which is, how do you handle situations where the underlying methodology or the underlying, sort of commitments to how we do things are inconsistent with one another? And what do you do about those? And, you have big scale things where you have, say, fundamental differences of opinion about how you come to the truth, like a religious community which thinks that, their religious text is authoritative. And so the way that you figure out truth is figure out what the religious text says versus a more, like what we think of as more empirically minded, we do science. But also even within what we think of as science, there are these things. When you see interdisciplinary communities where, say, biology and psychology, or economics and psychology, or one of these places where two different disciplines intersect with one another, you'll discover that the different disciplines have different evidential standards. And so what, might be regarded as, good scientific research by the standards of one discipline will be regarded as bad scientific research by the standards of a different discipline. And so how do you navigate those differences of opinion? And I think that this is a very tricky question because on the one hand, we want it to be the case that whatever their methods, we want it to be the case that they can discover that they're wrong. And so this may be a case where we say about the religious community, look, there's a fundamental assumption here that you're working on that you will never be able to discover that you're wrong. Because if your text is wrong, your method is not going to achieve that self-correction. Whereas we hope, at least for scientific methods, that those scientific methods may achieve self-correction. But it does mean also that I think we do need to be a little bit more tolerant of understanding that just because somebody uses a method that we don't think of as a classical scientific method, or within our own discipline that we don't recognize as like, that's not how we do things, that doesn't immediately mean that that method is not empirically reliable. So we can't just look at it and say like, oh, well, you're not using statistics, so therefore you must not be doing science. It's like, well, but actually good science was done for centuries before the invention of statistics. And statistics is important and valuable. And so I think we should use it. And there are a lot of places where we should use it where we're not using it. But also, it's not as though that line is going to be razor clear, that this method is good and scientific and this method is distinctly non-scientific and bad. And this is, I think, one of the things that people are starting to discover, when we start to look back at history, where there are very different methods, say, between how science was done in China, for 1,000 years and how science was done in Europe for 1,000 years. Now, there's this sort of, because a lot of us inherit the European history, we tend to think, oh, that the way that it was done in 15th century France is better than the way that it was done in 15th century China. But it's not at all obvious that that's true, because there are lots of mistakes. There was lots of bad science done in 15th century France as well as 15th century China, but there may be good science in both places too. And so I think this is one of those places where we need to reflect at somebody might have a method that's different than ours. And maybe it's bad, and maybe it's not science, and maybe it's the kind of method that will lead you to error that you'll never correct yourself from. But maybe it's not. And so, being a little bit more open-minded and thinking about what can that method teach me, if anything? And even if the method is necessarily wrong, is it possible that they've discovered something that I can use my methods to investigate? And that's, I think, been, one of the things that I think is really interesting, is that, it may be that the method, even erroneous methods, may lead us to theories that we wouldn't have come up with already. And so just because somebody came to a conclusion that's erroneous doesn't mean we should reject it. And this is something I always say about a lot of the things that I think of as pseudoscience. Things like all herbal medicines and things like this. It's like, I think it's important though that people distinguish. It's like their method is not necessarily going to distinguish between true and false conclusions, but that doesn't mean their conclusions are false. It just means that their method won't distinguish between them. And so it's not, just because you shouldn't believe them just because they say this herb will treat this disease. But it also doesn't mean that the herb doesn't treat that disease, that we should use our methods to investigate their conclusions, as opposed to just say, oh, because their method is wrong, their conclusions are necessarily false. No, that's not true either, right? It's because their methods are wrong, we can't distinguish truth from falsity necessarily using their methods. So we should use our methods to try and distinguish.
Yeah, actually, you've one. Not only did you knock out that description way better than I did trying to introduce the idea, but you brought up one of the ones that I sort of ruminate over quite a bit, just because I drink a lot of tea and why not?
Yeah.
But the idea was, for example, I guess I don't know what the euphemism for it is now, like natural medicines. There's also homeopathy and things like that. And I guess it seems like there are two areas in here where like my own biases incline me that when I see something like the words homeopathy or natural medicine around it, I'm inclined to not only be ambiguous about that belief, but actually reject that belief. And I would say that that's actually not a founded belief. I should at most only be ambiguous to them because I don't believe in their methodology. But at the same time, when you see things that are sort of like traditional medicines, homeopathy, things like that, there are places where simply because science hasn't filled in the gap and come to a more reliable communal conclusion, it does not mean that it obviously doesn't work. It just means that we're still ambiguous on that area. And so I guess obviously there's one of the ones where I'm trying to figure out, it's like, am I actually being rational or am I buying into is this how they get into people's heads or what is it?
And I think that that's exactly right. And I think that that's part of the polarization over some of these issues is really counterproductive because, the point of traditional medicine practitioners, they make a point which I think is very good, which is, because these things can't be patented, industry is not going to do a good job at researching whether St. John's wort is good for anything because nobody can make a ton of money off of it. So that's exactly where you might want the government to fund that, to figure it out. But just because industry is not incentivized to figure this out doesn't mean that it's true, right? It doesn't mean that this is effective. It just means we don't know. And so the polarization, I think, is exactly, you've got people who are like, no, that's all crackpot, so none of it can be true, so I won't research it. And that's a mistake. But also then you have people on the other side that says, see, none of them are researching, so therefore it must be true. And it's like, no, that's not right either. In reality, we just don't know. And so what, at least to my mind, what a good scientific community would do is say, here's a bunch of things. Some people think it works. Some people think it doesn't. Let's, as a community, work to figure out whether it does or not. And the polarization, I think, about these issues has tended to be harmful in this respect because it hasn't led that community to, either side of that community, to being responsive to the concerns of the other.
And I'd actually say I'll at least give the homeopathic apologists the following. At least they described a mechanistic approach for why they believe that this phenomena exists. So basically say, well, because there's not an incentive structure, and we know that there's not such an incentive structure, that these types of things will not be produced by traditional pharmaceutical means. And therefore, we believe that it's an underexplored area of research. And so
and
I'll
with
give them
respect
that.
to that, I agree with them.
Yeah.
I think that they're right about that. The problem is that then the next step is, and therefore we should believe that these work. And it's
No, but I do appreciate that mechanism description because I think that scientists across the board can always do better. And it's one of the things I've had a problem with a lot of machine learning work in healthcare processes where so many people are so interested in like a battle with the algorithms approach, or they just say, does this have better predictive accuracy than this, that they actually ignore whether or not they understand what sort of mechanism the interaction between the algorithm and the data and the human physiology, what is actually being captured here that's allowing you to do that. So on that one, maybe they've scored 1 point on us and we can at least do a little bit better. But cool. Yeah, I think that's it. Well, Kevin, thanks so much for your time today. Were there any other things that we should quickly knock out? Final thoughts? Or
no, I don't think so. I mean, obviously, as you said, there's tons of interesting things to explore in this area. But I think that this is one of those areas that it's on the philosophy side, ongoing research. So there's lots of open questions that people are sort of trying to tackle right now, and we don't have answers to. So.
Cool. Well, without those answers, we're still just we're a little bit more knowledgeable. We've discussed some, I'd say, interesting and difficult issues, including ones that just aren't comfortable to discuss. But the fact is, I think that by having these conversations, as we march out into the abyss, we're a little bit better armed to at least critically evaluate and see where people have gone wrong or right before.
Yeah. Well, great. Thank you, Glenn.
Thanks. Hey guys, it's Glenn. Thanks for your time today. I hope you liked today's episode. If you did, please consider smashing that like button. It's the single, simplest, fastest way to make sure that YouTube shows this video to more people. If you really want to go crazy, consider subscribing or going to our website and joining the mail list. If you want to go totally crazy beyond that, forward this to a friend or colleague who you think might enjoy this too. We're a small channel and every bit helps. Our next episode will be coming out next week, so in the meantime, feel free to look around the channel and see other videos that might be of interest. As a quick disclaimer, the views expressed in the show do not represent anything other than the people saying those words, views, etc. like that. It doesn't mean anything about their employers or their employers' views or some thing about their employers or their neighbor's cat or anyone else not saying the words. And in fact, given that people tend to change their views when they're thoughtful enough, it might not even represent the views of the speaker by the time you're hearing the episode. So definitely come back and see if they've changed their views at a later date. They also don't represent the views of our sponsors. Thank you to our sponsors. You can check them out on our website.